this is probably something a little bit different to what we've had so far. So it represents a whistle-stop tour through the challenges and solutions and opportunities of managing urban streams. As Clive mentioned, I was previously with Auckland Council, so I just put this slide in here just to give you some context as to why I'm here talking about urban issues. I was there for the best part of 8 years and spent a lot of my time working on urban fresh water in and around the Auckland region. And I've been in the consultancy world since January, so I'm still pretty green as a consultant. And I'd also like to acknowledge several people who have contributed to discussions and ideas that I'm going to present today. Obviously couldn't all be standing here, so people at Auckland Council, people at Greater Wellington, John Harding from Canterbury, numerous people through the SWIM group, through the years I've been associated with SWIM, and the 2 professors from Melbourne. So, urban streams. Globally, there's a pretty significant shift in the demographics of human populations. Urban dwellers, city dwellers are increasing at a phenomenal rate, such that we've got currently at the moment 60% of the global populations living on 3% of the land. And in New Zealand, that situation is probably a little bit more extreme, where we have over 50% of our population living on less than 1% of the land. Now, this land use map on the right-hand side, you can see if somebody didn't know New Zealand, they'd struggle to find the urban centres. So those 3 circles represent the main 3 urban centres where over half of the population of New Zealand live. Now, the pressures created by these intensity of people and their resource demands lead to significant environmental effects across a whole range of environmental domains. In stream systems, these have been particularly well described, and they include effects on morphology of streams, hydrology, water chemistry, and ecology. Now, these effects are predictable and widespread. They've been recorded from virtually every urbanised centre across the globe, and they've led to the definition or the description of a syndrome called the urban stream syndrome. And here's some evidence that it's alive and well in New Zealand. This is some data from Auckland Council's monitoring programs. On the left-hand side, we have a map showing water quality locations, and on the right-hand side, we have a map showing ecological monitoring locations based on invertebrate communities. And we see on the left-hand side, hopefully I'm not blocking you, the red dots correspond to those water quality monitoring sites that fail one or more of the NOF bottom lines. And you can see there's a preponderance of red dots in and around the urban area. And on the right-hand side, this is the invertebrate monitoring, the ecological monitoring. There's more sites in this monitoring network, hence we've got more red dots. But essentially those red dots represent sites that have an MCI value of less than 80. So in terms of the national guidelines for reporting MCI values, they're considered to be in poor ecological condition. Now, the data is presented on the next slide in a slightly different way. It's the same underlying data, but it's just represented in a graphical format. And the take-home message from this one really is just to show the extent of degradation in urban streams is typically far greater than the other types of land uses we subject to our streams. We see a pretty consistent and predictable gradient of decline from our reference sites on the left-hand side of the chart through to our urban sites on the right-hand side of the chart. So I guess the point here is together that the extent of urban area it may be quite low, but the degree of impact on our streams, urban streams, is consistent and it's quite severe. And the next slide just demonstrates some of the morphological changes that happen to stream networks. This is a time series photograph of some urban development that occurred in Auckland between 1992 and 2006. You can see there's a blue stream network. The yellow circle is an Auckland Council monitoring location. And the stream is essentially flowing to the upper left-hand corner of the pictures. And as you can see, as the development occurs, the upstream of the monitoring site, the catchment is essentially piped and replaced to the, by the last picture by a stormwater management pond. So we've not only added water quality issues here, but we're actually physically losing streams. So these streams are buried, and for those of you who know the area, this is Botany Town Centre, and essentially those streams are never going to come back to the surface again. So this is quite a common occurrence. For example, in Baltimore in the US, 66% of their streams were drowned. Within the last year, I've also been involved with a structure plan that proposes to pipe and divert 10.5 kilometres of stream. So I'd like to say this is a legacy issue, but it's ongoing and it's happening. And at the moment, the national policy statement is silent on this issue. In fact, a possible perverse outcome could be that we pipe our streams to avoid having to comply with national bottom lines, because water in a pipe is not water. So what are some of the stresses involved in urban streams? And it's really important to note that it's not a single problem with a single cure. The relative weight of these stresses that are listed on the board will vary from place to place. And I think it's really important, building on Richard's talk, to talk about mitigation, is that accordingly the mitigation or the management of that urban stream will vary from place to place depending on the relative mix of these stresses. And the next slide is really just to show that, demonstrate that point. This is a collection of New Zealand's finest urban streams. And what we're really showing here is that just from looking at these from the images, logically you can see there's different stresses acting here in different locations. And then we need to be cognizant of this as when we develop our management approaches. So what are some of those stresses? I thought it'd be useful to look at a couple in detail. So the next slide looks at metal concentrations. So it's a water quality measure. There's a just simple graph. There's the same water quality data from Auckland Council's monitoring program. On the left we have copper, on the right we have zinc. And it's a little bit of quirk of Auckland's monitoring program. I've never really noticed it until I plotted this graph, but most of the urban streams begin with O or P. So they tend to be in the middle because these are ranked alphabetically across the bottom. Bizarre, I know, but there you go. And the red line on here is the 80% ANZAC guideline. So this is the most permissive of the ANZAC guidelines. For example, the zinc one, the more conservative one, is an order of magnitude lower. So these are really quite permissive guidelines, and we can see that most of the urban streams are above the ANZAC guidelines. And then how do we use that information in a limit setting context? Well, it's quite difficult. Hopefully you can make this up. This is some work done by Auckland Council about 7 or 8 years ago, and it looks at the sources of these metals in the urban environment. And on the left-hand side we can see copper, the big red triangle at the bottom. The most obvious identified source of copper in urban stormwater was from brake pads, from vehicle use. On the right-hand side, zinc, the red section again is around car tyre wear. So zinc's added to car tyres as a strengthening agent, and so that as the tyre is driven around, the car is driven around, tyre wear onto urban surfaces and discharged into the nearest stream. So setting limits for those two things is incredibly difficult. That's something that any regional authority in New Zealand will have very limited ability to change the composition of car tyres and brake pads. So it's quite an intractable problem. And the next slide talks about another stressor, and this is arguably this has been presented as the most significant stressor in urban streams. It's altered flow regimes. It's a pervasive influence across all urban streams. We see it everywhere, and most of the literature would say this is the biggest issue in trying to manage urban streams. And these are just a couple of diagrams that I've borrowed from the EPA in the States. On the left-hand side, it's just showing what happens to rain when it lands on a natural system, and on the right-hand side, what happens when rain lands on a developed area. And there's one or two numbers in particular I want to draw your attention to. Hopefully you can see those orange boxes, and that's the runoff. So in a natural system, about 10% of the rain that falls on that natural system runs off the surface. In an urbanised system, for these ones, so this is a moderately urbanised system as well. For extremes, it gets even higher, but 30% of the rain immediately runs off those impervious surfaces. So there's obviously a threefold increase in runoff. And the other thing to note on here is the reduction in infiltration into the groundwater, which contributes to stream base flows recharge. So the combination of those two things is that you end up with modified hydrographs. Now this one here, again, is another one from the EPA, and there are two lines there represent two different streams that are very close together, similar geology, similar climate, but the main difference is one's urbanised and one's not. And there's 2 points here really to look at, and one is the red line and how high it goes following storm events in comparison with the green line. And following even moderate rain events, the discharge in that stream can be 5 to 6 times higher than in the undeveloped stream. And then the other side of the equation is you look on the green line, the base flow between storm events is higher in the undeveloped catchment. So urbanisation, we get a double whammy on hydrology. We get much higher flows after storm events, so there's much more disturbance, And then in between events, we get less water, and those streams are more likely to become intermittent or have low flows in them. And these next two images are favourite ones of mine from Auckland, I'm assured, which really show this at a really extreme scale, and some of you in the room will probably recognise them. But this is the sort of thing that can happen with regards to altered modified flow regimes in urban systems. It doesn't really matter what the water quality issues are, what the quality of the water is in that catchment. There's not really anything that's going to be able to live or survive in that environment.
What happened to the bloke standing in the picture?
I think he's chained to the railings. Wasn't you, was it? You might know about it. So one of the questions I'm also asked as well in Auckland, and I thought it was useful just to put this slide in, was why do we really care about small little grubby urban streams? Most people in urban environments turn their back on them. They build fences so they can't see them. They pipe them underground. And I think by neglecting urban streams and by not managing them properly, we're just essentially transferring the problem downstream to the receiving environments. And again, this is another map here, which just shows on the right-hand side, this is based on sediment contamination, and all of those red dots, which are all in estuaries and marine receiving environments around the Auckland urban area, are breaching all of the sort of standards for healthy benthic communities in the marine environment. And this is also, I think, highly relevant to the MPS and its direction that we should consider the interaction between freshwater and marine. So how do we manage these urban streams? Let's try and focus on some positive. There's two reissues, and I've just put this map up again, really. There's two spatial issues. There's one we've got to deal with, is our existing urban areas. How do we remedy those? So we know they're degraded, we know they're in poor state. What can we do about fixing them? And the other one is, what do we do about future urban areas? We know in Auckland we've got to accommodate another 1 million people over the next 20 to 30 years. If we carry on urbanising like we have urbanised in the past, we're just going to end up with more red dots on this map. So we really need to think about how can we do things differently going forward. And I'll address the second point first, largely because it's easier. There's, depending on what hemisphere you're in, low impact design in the northern hemisphere or water sensitive design in the southern hemisphere, it's the same basic thing. It's essentially an approach to development where you're managing fresh water in a more holistic way, and you're including things like rainwater harvesting in your developments. You're including methods to increase infiltration of rainwater into the ground, and also at source stormwater management, which also aligns with what Richard was saying about the effectiveness of mitigation options are more when they're near their source. So this is the general approach, general philosophy to this approach. And there's mounting evidence around the benefits of low impact design or water sensitive urban design. There's studies from across the globe now, including in New Zealand, where we're seeing improved outcomes associated with using low impact design techniques, including hydrological, water chemistry, and also ecology. So the issues there, it is a solution that can be used to fix some of the future urban issues. The main issue, there seems to be an implementation barrier associated with the cost. Now, this is still an area that is subject to a huge amount of debate, quite controversial and quite heated debate, about where the costs lie for LID or conventional stormwater management. In a current environment, I'm sure you're all aware of the drive for affordable housing in Auckland, so anything that adds money to the cost of a lot or a house in Auckland is not particularly palatable in a political sense. But the cost of these low impact designs has been estimated between $5,000 and $50,000 per lot, depending on which camp you're in, so there's still a lot of uncertainty that needs to be addressed here. And depending on where that estimate falls, that could be quite a small proportion of the average house cost, or it might be quite large. But even greater, and though, in the cost debate is what are the life cycle costs? So quite often we focus on the upfront costs of doing LID, but if we don't do LID, what are the life cycle costs of the conventional stormwater infrastructure and maintenance we have to manage to deal with those ongoing problems that from the stormwater management? Nevertheless, there are areas where LID is being implemented at a large scale. So this is an aerial photograph of Long Bay in the north of Auckland. I went through the Environment Court probably about 10 years ago now. Some of you might be aware of it. And essentially this is one of the few examples where low impact design is being applied on a scale where it really be able to make a difference. This is a housing subdivision of 2,500 lots. Existing urban, how do we go about managing existing urban? And I sometimes get accused of being a bit negative, but nowhere in the world have we successfully restored an urban stream once it's been degraded. It's a pretty hard-hitting statement, as the guys reminded me this morning when we did a run-through. But essentially, there are areas of urban streams that have been cleaned up and made a little bit better, particularly associated with the management of point source discharges, and the River Thames and the River Rhine are two examples that are quite often used. But fully restoring a system with a functioning ecosystem is still beyond our grasp. However, I see this as a problem that we can turn into an opportunity. Most of the urban restoration projects that I've seen have quite obvious failings or issues with them that are associated with that failure, and it can be used to explore them. Two of the biggest ones I've mentioned on the bottom here are intervention logic and scale issues. And I'm just going to illustrate these two with a couple of case studies. And before I mention these case studies, these are not a criticism of those case studies. They're really just showing you the process that we need to go through when we're managing urban streams and managing existing urban areas. Both of these case studies have won Environmental Steward Awards. Both of them have achieved probably significant social amenity outcomes, but one of the things they haven't done is achieved meaningful freshwater outcomes. And the first one is Project Twin Streams. If we're solving a problem, and I think Richard mentioned it as well, we need to diagnose what the problem is, what's the cause of the problem, and then target our management accordingly. And that's not really happened in Project Twin Streams. It's secured a huge amount of funding, most of which has been used for procurement of flood-prone properties and also the creation of cycleways. But there have also been nearly 800,000 native plants planted in the catchment, which is no mean feat and is obviously likely to lead to a whole series of terrestrial biodiversity benefits. But one of the big problems here is we're using riparian planting in an urban context. Now, this is a management tool that's been successfully used in rural systems that we've just picked up and we've applied in a urban system. And the image down the bottom here shows what the problem is that most of the stormwater management issues in an urban catchment, they're piped directly into the stream. So there's no opportunity for riparian planting to really filter or work its magic on the overland runoff. So the point here is that we need to be thinking about what's the problem and addressing that problem with a targeted solution rather than just taking these one-size-fits-all management opportunities in various places. And the next one is a daylighting project that happened in Auckland, urban Auckland. And this really demonstrates where the scale of the management response is outweighed by the scale of the impact. There's a time series down the right-hand side which shows the nature of the project. And this was another project, pretty expensive, over $2 million. That equates to about $12,000 per metre of stream restored. So if you imagine trying to do that on a large scale, it's pretty significant investment. And what we've seen is that we've got quite excited about daylighting 100 metres of stream, which is fine. It has some positive aspects to it. But the real issue from a freshwater perspective is that there remains 4.7 kilometres of piped stream upstream of that location in the catchment. So we're really, it's really picking at the edges. But that would be fine if it was part of a strategy, potentially the first step of many to restore that catchment, or if it was deliberately done to raise the social profile or the profile of urban stream restoration. But this project one of the objectives was to improve water quality outcomes. And the two plots at the bottom just show some of the ecological monitoring we've done. We've sampled invertebrate communities every month since the stream was daylighted. The dark bars represent what was living in the pipe before it was daylighted, and the grey bars represent the samples taken since daylighting. And I don't need to do a statistical test to say there's not really a lot happening there. Cool, thanks, Clive. I think I'm nearly done. So rather than be negative, I really wanted to say what could be done. So this is probably the closest thing in the world that I'm aware of to an urban stream restoration project, a successful one. It's in Melbourne. It's the Little Stringy Bight Creek, which is an interesting name in its own right. And it's a catchment that's been undergoing some restorative actions over the last sort of 10 or so years. It's a multi-organisational project. The water providers are involved, the universities are involved, the local councils are involved. Most of the work is done through mobilisation of social groups, so it's still got some consistencies with the projects we've used in Auckland. But it's quite a small catchment, so they deliberately targeted a catchment that was small enough where they could make a difference. They deliberately targeted a catchment where some of you may be familiar with the impervious cover model where you get a response. They deliberately targeted a catchment that was near the threshold of change, so it was easier to move it back and get a response. So this is a 2.5 square kilometre catchment, so it's not very big, and they've introduced 280 different stormwater management devices in that system, with the intention of increasing the harvest of rainwater, the infiltration of rainwater, and also the treatment of stormwater quality and quantity. The outcomes associated with this project, so we've now got 89% of the impervious surface in that catchment is now captured and treated by these stormwater management devices. There's nearly 17 million litres of rainwater that is harvested every year and reused for domestic purposes. And we've started, they've observed measurements in increased base flow, so hydrological response in the catchment. They've observed responses in water quality, water chemistry measures. They're yet to see a response in ecological measures, but if you were thinking about how a stream might respond, the ecological responses would naturally become later down the track. So it's not all doom and gloom. These guys have done it. They've been tactical about where they've done it. They've been tactical about how they've done it. And they've managed to pull off a pretty successful project thus far. So just a concluding slide. What can we do? Along the lines of Little Stringy Bark Creek, I think there's an opportunity for us to recommend, harangue, however we do it, harass people to potentially explore the option of a case study urban catchment. If we can somewhere in New Zealand get an urban catchment, trial some of the restoration tools and make a meaningful difference, I think the impetus that would create would be huge. We have existing best case catchments, case study catchments, there's dairy, best practice catchments. We've got the research station at Whara owned by Tainui, which is another great example, but it's all rural focused. We have nothing in the urban space. The second point is I think we need some sort of mechanism to prioritise our management of urban streams. Quite clearly we can see from Stringy Bark that there's the level of investment required, we can't do it everywhere at the same time. So we need a robust mechanism to allow us to sequentially deal with some of the urban issues going forward, presuming of course we can. And then there's also some opportunities to include some more urban relevancy to the national policy statement. First and foremost, this could involve some urban-focused NOF attributes, and obviously copper and zinc are the two ones I've showed you from Auckland, notwithstanding the issues around monitoring or managing the sources of those because they're at an international scale. And the last one is really a recognition that water quantity is not all about abstraction. Hopefully the hydrological issues here that I've highlighted demonstrate that it's not about how much water you take out of urban streams, it's about how much we put in. And that's me.